Here's a strange, beautiful fact. You can turn the meaning of a sentence into a point in space. Take I love dogs and I adore puppies. Different words, same idea. They land right next to each other. Now take I love dogs and Python is a type language. Those drift far, far apart. That's an embedding, a list of numbers that places a piece of text somewhere by meaning. Picture a flat map. Cat sits near kitten, dog sits near puppy, but also near cat because they're both pets. Python, way off with Java in the programming languages corner. Bicycle floats off on its own. That map is a tiny embedding space. Real models don't use 2 dimensions. They use hundreds, even thousands. 384, 768, 1536. You can't draw it, but the geometry is identical. And once text is a point, similarity becomes a ruler. How close are these two vectors? The default ruler is cosine similarity. It looks only at direction, the angle between two arrows. Pointing the same way scores 1. At right angles, 0. Pointing opposite, -1. Length is ignored. There's also straight line distance and the dot product, which is just the fast cousin of cosine. Here's the quiet trick of the whole field. Most embedding APIs hand you arrows of length exactly 1. When every vector has length 1, cosine collapses into a single dot product. No division, pure speed. That's why vector databases lean on it. Normalized in, dot product out, similarity for almost free. And here's a newer lever worth knowing. Modern models pack the most important information into the first dimensions. So you can chop a 3000 dimension vector down to 500 and keep around 93% of the quality. Cheaper storage, faster search. And because meaning becomes position, similar texts naturally clump. Feed them to clustering and groups appear. Text sentences gather here. Fitness sentences gather there. Nobody labeled them. The geometry did it alone. Want to actually see it? You squash 1000 dimensions down to 2 with PCAA or TSNE and plot the points. That scatter plot is the first thing every debugging session reaches for. Do my categories actually separate in vector space or not? But geometry can lie and you have to respect that. Tiny text like yes and no smear together meaninglessly, so don't embed single tokens. Domain jargon fools a general model too. Trained on the open web, it may not tell a long position from a short position in finance. And here's the one that really bites people. The capital of France is Paris. The capital of France is London. Those two embed almost on top of each other. The embedder knows the topic, it has no idea which one is true. Embeddings model similarity, never truth. Judging fact from fiction, that's the language model's job, not this one's. So that's the engine. Text becomes a point, closeness becomes meaning, and search becomes finding nearest neighbors. Internalize that one move and semantic search, recommendation, and retrieval all turn into the same simple geometry.